Hello. I'm going to talk about libratbag, which is a daemon to configure input devices. So who am I? My name is Philippe Lynch. I like beer. I'm a student. I'm one of the maintainers of libratbag, and I package some stuff for Arch Linux. So the table of content, I'm going to explain a bit better what is libratbag. Then I'm going to talk about the current status, what we have planned for the future, and a really quick overview of the IT protocol. Then how you can define your own libratbag driver. Then some questions. So what is libratbag? Libratbag is a dbus daemon to configure the hardware of input devices. So, for example, some IM devices like this one, you can change the sensibility and other aspects of the hardware, but they often, the manufacturer often only provides official drivers for like Windows and sometimes maybe Mac, but never Linux really. So if you buy such an expensive mice like this one, you want to be able to change those settings, and that's what libratbag allows you to do. We are vendor agnostic, so our API is not tied to any particular vendor, so you can define your own driver for any mouse or any other kind of input device, and have it work. So right now we mainly support Logitech because they actually use a standard protocol between all of their devices, so it's really easy to not necessarily maintain, but to have the same code work for different models. While other vendors like SteelSeries have like a different protocol for each hardware, so it's a bit of a mess. And libratbag was created in 2015 by Benjamin Tissoir, who is one of the maintainers of the id subtree of the kernel, and Peter Utterer, who is the maintainer of libinput and most of the Linux input stack. So what can you configure with libratbag? So you can change the resolutions, so the DPI settings, you can change the report rate, you can remap buttons, you can do hardware macros, and you can change the effects of the LEDs. So for clients, we currently have Ratbag CTL, which is still SLI client, which is CLI client, but it's mostly intended for debug. And we have Piper, which is a GTK client, which is mainly which is intended to be like a proper client for end users. So the status of libratbag, so it works. You can change all of settings for the supported devices, but we don't have any. We don't have a stable client API yet. So because of several issues, like we have limited time, we are not. We don't want to define a stable API yet, because we will have to, if we do it, we will have to maintain it, and we hope to be able to do it soon, but it's not there yet. So the issues that we currently have with libratbag, like I said, we have limited time. We don't have that many maintainers, that many contributors. Most the people that contribute to libratbag mostly make their device work and don't really contribute to the rest of the code. So you can have some part of the code for some device that works perfectly fine, but for other hardware it can be a little bit buggy because the people that contribute to that code are not that active. So it's one of the issues is can be hard to maintain. So some of the code, if you don't have some previous knowledge of the ETH protocol, which is the protocol used by input devices, it can be a little bit complex in some parts, but you usually don't have to deal with it. Me and the other maintainers have to deal with it. And I think the most important thing is that we have limited access to hardware. So I do not own all of the hardware that we support, and neither do the other maintainers. We have, between all of us, I think we have a good portion of the hardware, but we don't have all of it. And that can really that can really prevent us from fixing stuff because we don't have the hardware. So about the future, we want to set up a CI, but to test the hardware drivers, because they communicate with hardware, we need the only way for us to test them is actually emulate the hardware. Otherwise, we don't have any way to. We will have to have like a physical CI, which is not great because, like I said, we don't have all of the devices and it's hard to maintain. So what we want to do is to have device emulation. So this summer, Logitech was kind enough to give me an internship where during the summer I worked on open source software, and one of the most one of the principal the main projects of the internship was to create a device simulator. So right now we have a device simulator that works. We have a prototype, and we have a prototype CI for libratbag, but it's only a prototype. I am rewriting the device simulator. It should be ready soon. So hopefully soon we will have like a proper CI that can emulate all of the hardware, even if we don't have it, and can actually make proper regression testing, make sure that new changes don't break existing code and things like that. One other thing I wanted to play around with is color synchronization. So, for example, if you have a device like a mouse and a keyboard, you could actually have the light effects sync up between them. Or if you have like other kind of devices that we could support, you could have everything nice and synced up, have the same color effects between everything. So I'm going to talk just a little bit about the ETH protocol, which is the protocol used by input devices. This is supposed to be like just an entry point for people that want to understand how these input devices interact with the computer and how they operate, and on top of that, how the protocol for how the protocol to configure these devices relates to that. So so you have a device. This is one of the most common examples. For example, you have a mouse, and every time the hardware changes, the hardware state changes, you send a report to the host telling, okay, so I moved x dot in the x axis. So, but the ETH protocol is designed to work with all kinds of input devices, and they have different hardware properties. So we cannot have like a standardized report structure. So the packet that the device sends to the computer to tell it what changed in the sorry, to tell it what changed, it cannot be standardized. Otherwise, we will have like a really big packet because we need to send everything that is possible. So to prevent this, the ETH protocol defined report descriptors, which are basically structures that describe how the packet is structured. So, for example, in this simple example, you have a mouse, and every time the hardware state changes, it will send 3 bytes to the host, updating the state of the buttons. For example, in this case, the buttons byte is just a bit mask. Every bit represents 1 button, and then you have your 2 axes. But the ETH protocol cannot really be. It's not broad enough to be able to define all of the things that you could be able to configure in your device. For example, the sensibility or some other crazy things that the vendors might want to do. So they defined. So they allow you to define a certain part of the packet as just vendor data. So in a more complex event, you could have a report descriptor that says that the packets that start with 1 send the basic mouse hardware updates, and the reports that start with 2 just send vendor data. And at this point, the ETH driver, the generic ETH driver, will just ignore this data. It knows what to do with that one, but it will ignore the vendor data. And then you can have like a vendor driver to deal with that data. And that is what libratbag does. We interact with the vendor data. So every vendor will have a protocol inside this vendor data, a way for us to configure the devices and talk with the devices using this vendor data. In Linux, you have 2 ways to interact with the vendor data. You can have like a kernel driver, but that's not really a great solution. You really only want to do it if you need to. If you need access to that data somewhere inside the kernel. The most common example is the battery reporting. So you can have the battery reporting show up in sysfs, and then have upower pick it up and report it natively. And for that, you could do a kernel driver. But for all of the other things, like configure the LEDs and things like that, you don't really want to do a kernel driver. You can do it in user space. So the kernel will export a def ETH-RAW device, which is a device that just sends the raw data to the which is a file descriptor that only that sends the raw data to the device. So in libratbag, to write your own driver, you basically create a new file and you define some functions, and then you define this structure. the structure the structure can vary a bit, but for most cases you want to define a probe method, which is every time you update something, some setting, it will be called. Sorry, no. The probe method is the first time that you connect the device. Then you have a remove method that is when you remove the device. Then you have the commit method that is every time you update some setting, it will call that method. And usually what you do is just to take that to send to tell the device to be configured in that way. So I can, if anyone has questions, I can answer. Otherwise, I can show you a demo. I mean, I don't know if you know. Yeah.
What's the current status of programming the internal memories of some mice?
The status of programming the memory of the some mice. So most of most devices don't really allow you to interact with that because they just the firmware only. The thing is that, sorry. So you have the device that is connected via USB or something, and you have the protocol on top of it. It doesn't. Most devices don't really have a way for you to interact with the memory. For example, Logitech devices, particularly with onboard profiles, actually export like emulated memory, where you can store stuff. It is used to store macros. In more recent devices, like some custom LED effects, you can in those devices you can actually using the vendor protocol you can write to some part of the memory, and you can do some stuff with that. But most devices don't really allow you to interact with the memory. It's basically you just most devices only have like really simple commands that you say, okay, set the LED to the color red, and then the farmer receives that message and interprets it and does that sets the LED to red. I don't know if I answered your question properly, because just most of us don't really allow you. There's no interface to write directly to the memory, because after all, this is just an MCU running some firmware that will just get the updates from the sensor and then create some IT packets with the updated state and send it. So it's you can only do what the firmware allows you to do. I mean, in some devices you can actually open them up and reprogram it, but that's a bit out of the scope. I mean, anyone else?
Yeah, is libratbag only supporting HID devices? Like, I do have a mouse where I reverse engineered the protocol, but it's not. Well, it isn't a HID. So should I write a kernel driver to emulate an HID device?
I mean, I don't think you should. Sorry. Okay. What you are asking if you are told that you have a mouse that allows you to configure it, but doesn't export an HID device. So in that case, I don't think you should write a kernel driver. Right now, all of the devices that we support are HID devices, but I don't think that we need to do that necessarily. I mean, we have to talk with the other maintainers, but we might want to have that in libratbag, because after all, it's just a daemon that takes your device and exports some settings. So resolutions, import rates, LED effects, things like that. And your device matches that profile. So, anyone has any questions?
Do you have to use libratbag to get stuff done, or can you just write something that uses libratbag to go and configure devices directly via HID?
Okay, so do we need to use the libratbag, which is the daemon, or can I just use libratbag to do what I want? Kind of deprecated, and we just merged the daemon and the library, and right now we only publicly support the daemon, because I was not involved with the project when that happened, but I think it was because it was hard to maintain a public API for the library, because it was in constant development, so they didn't really want to maintain a public binary API. So I think that's what happened, but I'm not entirely sure. So, anyone? Any questions? No. Okay. I can show you a demo. So I'm going to connect this mouse. I forgot the receiver, but I can connect it directly. So, okay, my device shows up. Then I have resolutions. I can change that, can remap buttons. For example, I think one of the most important things is, for example, if you are left-handed, so you want to switch the two main buttons. If your mouse is supported in libratbag, you can just go here, and by default it will just pop you this interface where you can just do it, and then it's remap. Then you click apply, and then and now the buttons are. Let me see if I can. Okay, yeah, I need to do this. The buttons are mapped. I need to use the other button. Yeah, okay. So then we have the LEDs. So I can just put like this orange. If I do this now, let me show. If I click apply, it should go orange. Okay, it went. Yeah, that's basically it.